Hello everyone. Today we're testing a classic quant question. Is GARCH actually better than a simple naive volatility estimates for USDIDR? We'll do it properly. Walk forward. No look ahead. Forecasting 5-day integrated variance. And we'll judge models using a loss function traders and researchers love. QLIKE. Why do we even forecast volatility? Because in trading, volatility is not just a statistic. It's position sizing, risk limits, stop distance, and often the inputs in derivatives pricing. Markets also show volatility clustering. Calm periods tend to stay calm, and crisis tends to stay crisis. So the first model most quants learn is GARCH, because it's designed to capture exactly that behavior. Here's what we forecast. We convert USDIDR prices into daily log returns. Then the realized volatility target we evaluate is integrated variance over the next 5 days, sum of squared returns from day t to t plus 4. For the naive baseline, we take a rolling variance, then multiply by h, and importantly, we shift it by 1 day so it uses only information available at time t. No cheating. Then we run walk forward at each forecast origin date. We fit GARCH using only the history up to yesterday and forecast the next 5 days. Finally, we score everything with QLIKE, which punishes misestimated variance in a way that's robust and widely used in volatility forecasting. Now let's look at the time series on a normal scale. Blue is the realized 5-day integrated variance. Orange is GARCH forecast. Green is the naive forecast. Immediately, we see the huge spike around early 2020. That's the crisis period where realized volatility exploded. Visually, both models react, but not perfectly. And after the spike, everything compresses again. This chart is useful, but it hides a lot because most days volatility is small. And the crisis is massive, so we switch to log scale. Now we can see structure across calm and crisis in the same view. Those dots mark the crisis origins. I defined crisis as the top 10% of realized integrated variance. Here's the key observation. In calm regimes, forecasts often look very close. But in crisis regimes, differences in response speed and magnitude really matter. And that's where a model can win or lose, even if average error metrics look confusing. This is the calibration view. Each dot is one forecast origin date. X-axis is forecast IV. Y-axis is realized IV. The diagonal line means perfect calibration. On log-log scale, we can judge the whole distribution. Small volatility days and huge volatility days. What we want is points roughly around the diagonal. And especially we want to avoid systematic bias. Consistently under-forecasting crisis or constantly over-forecasting calm. Now this slide is not for calibration. It's for diagnosing why results look weird. On linear scale, you see something striking. Naive forecasts are compressed to a small range, while GARCH occasionally outputs much larger variance forecasts. So 2 things happen. First, the dot cloud near zero gets squashed. You can't see structure in calm periods. Second, outliers dominate traditional error metrics like MSE and MAE because those metrics explode when a few points are extreme. That's exactly why we also use QLIKE and regime breakdown, because they behave better for volatility forecasting. Now we answer the real question, who wins and when? Start with the regime bar chart. The score here is mean QLIKE, lows better. What we see is, in calm periods, naive can look competitive. Sometimes even slightly better, because volatility is stable and a rolling estimate is hard to beat. In crisis periods, GARCH can win, because it adapts faster to clustering and changing variance. Next, look at the cumulative advantage curve. It's the running sum of naive minus GARCH QLIKE. If the curve goes up, GARCH is adding value. We see a big jump around the crisis. That's where GARCH earns most of its edge. Then performance can flatten or even give back some edge in later years, which is normal. Markets change, regimes shift, and models are never permanently superior. Finally, rolling advantage smooths the story. Positive values mean GARCH has been better recently. Negative means naive has been better recently. This is the trader view. Is my model working right now? So what's the takeaway for quant trading? GARCH is a great first serious model because it teaches you the core idea. Volatility is dynamic and clustered. But performance depends on regime and on how you measure error. If you only look at MSE, a few tail events can distort everything. That's why we use walk-forward testing, regime splits, and QLIKE. Like, subscribe, and I'll see you in the next one. Thank you for watching.